Hi, this is Bob Fossil. This is a follow-up video to the speed lock cracking video that I released. In that video I used a +2 and a tape copy of Wizball, and we went through the process of removing speed lock protection and then saving the files back to Exodus and then creating a little loader program for that. So in this video I thought I'd do the next logical thing with that and show how we can use the monitor program to try and do an infinite lives poke for Wizball. So I'm going to show two methods to do this, but the first thing we need to do is we need to load in the Wizball that we had from last time. So we need to do a bit of reconnaissance and see what we're dealing with, so just start the game off. I do apologise, this video will contain scenes of me trying to play Wizball, so if you know that triggers anybody, I do apologise. So you see down the bottom there we've got 3, so I'm assuming we've got 3 lives, so we're just going to try and get ourselves killed. So yeah, that's knocked down to 2. Should be 1. And we don't got 0 lives, so from that we've learned that we start with 3 lives, we go down to 0 lives, and when we run out of lives we get a game over message. So if I press the NMI button and break in with the monitor, so the first method is we're going to look and try and find where the game initializes that 3 lives. So on the Z80, an easy way to do that is to use the accumulator register, and load that with a value of 3. So we need to try and search for the opcode sequence, load A, the accumulator, with 3, and then use that, and hopefully we can then sort of find the bit where they get, because every time you restart the game your lives have got to go back to 3, so there should be some code somewhere in the Wizball game which sort of does that, and I'm assuming that they've used the accumulator and 3 to do that, because that would be the easiest way of doing it. But that's not necessarily the case with some games programmers that do it difficultly, but we'll try the easy way first. So we'll do a find for 3E, full stop there, comma 03. So that's the opcode load A, comma 3, and we'll start searching from address 2400. So that's chucked up a couple of candidate addresses. So if we have a look at disassemble, what we'll do is we'll just disassemble a bit back from that so we can get a bit of context to see what's doing. So if you take the first address 37175 and then knock 5 bytes off that and then disassemble that, so yeah, we see we've got a bit of code there, and then there's the 37175, there's our load A, comma 3, and that's then been loaded into 47431. So what we're going to have to do is we have to basically whittle our way through that list. So we can use a breakpoint feature in the monitor. So if I put a breakpoint on 37175 where that load A, comma 3 happens, start the game back up, press the fire button. Oh, our breakpoint's gone off, so that's a good sign. So that was doing that before the game started. So have a look at that. Was it 4? 37175. We have a look at what's in 47431. That's got FF, and again that's interesting because remember we had 0 lives, so if we were decrementing a life counter, if you decrement 0, because it's an 8-bit value, that will then wrap around to FF, which is 255. So again, this is looking promising. So what we'll do is we'll trace that. So that load A, 3 has now happened, and we switch the monitor into hex mode, he says. So we look at the 4th line of the AF, we can see the A register, because the registry pairs, that's now been loaded with 3. So what we want to do is we want to see if that 47431 is the lives counter. So what we can do is we can use the register set command to set the pair AF, and if we set that to 08, we need to set 44. So that will set the A to 8. So if that's set the A to 8, we now exit the code, exit back to the game. Life counter now says 8, so we know that that value 47431, is it? That's the life counter, because now we've got 8 lives. So yeah, just to show that, if we lose a life, that should now go down to 7. Yeah, that should now go to 6. So if we break back in, go to the monitor, then if we now we know that that address is the one that we're interested in. So if we just do 37175. So really we need to find references to that 47431 address, because that's we found out that's the lives count. So do a find for that address, and we look from there. So again, we're just going to have to go through these one at a time and see what we can find from these addresses. So 37050. So if we work back a bit, so we've got a bit of. So we're doing a halt, push B, as we disable. So if we go 3704. So we're loading A into loading the life counter into A. Well, that's the load A with the brackets 47431. We're decrementing the accumulator, and then we're loading that back in. And then we increment A, and then it does JPZ. So I'm guessing that JPZ is a call to the game over routine or something. Because remember then when we looked at that, before we got reinitialized, it was FF. So that's if it was 0 and you decked A from that, it would be FF. So we need to take that, stop that decrement at 37052. So if we do 37052 and poke in a NOP opcode, which is 0, disassemble 37048. We've got NOP there, so exit that. Notice our life counter is still at 6, and we just killed again. So we've got infinite lives. So that 37052, if we poke that with 0, that gives us infinite lives. So we've found the bit of code in the game which initializes the live routine, and then we use that to find the life counter, and then we found code that referenced the life counter. We got lucky both times because we had those big lists of addresses, and the first ones we looked at were the ones we needed to do. So I said there was 2 methods. So if I reset that, load the game in again, I'll show you another method you can do to find infinite lives, and I'll break in there just in case we get copyright strike on the Wizball music. So do you remember when we looked at the game that when you die it prints up a game over message? So what we can do is we can look for a string. If we do a search for game, search from 24000. So that's found just one instance of that. So if we have a look at that with the memory, 4186 1860. So we've got, that's the game over message. So we've got 53 20 20 0. So that's some previous text, and then we've got the 47 41 4D4. That's the game over. So you know that we can then look for that find. If we do find for that 41864 2400. That's found one reference to it again at 37126. If we disassemble 37120, if we just back up a bit so we can get a bit of context, we can see we've got that 37125 is load BC with 41864, then load DE with 20552, and then call 37916. So without really looking into it, I'd suspect the 41864 is a string for game over. The 20552, that looks like a location in the screen memory, and the call 37916, I suspect that's like some sort of print route, like a general string print routine. So the BC is the text to print, and the DE is where to print it on the screen. So before we've got that 37122, we've got a jump. So what we can try and look for is, you can see if there's any references to that 37125. So if we do 37125 24999, that's the start address that I'm searching from. And we found one reference again at 37058. So if we do it, disassemble back up again from that, just so we can sort of see. That 47431 looks familiar, doesn't it? So we basically, if I back up a bit more, 37048, we're back in the routine that we found in the first method, the 37052, but we've come at it from a different direction. We've worked backwards from the game over message. We found out where the game over was printed, and then we found the reference to the code that called the printing over for that, and then we've ended up at that 37052. So yeah, we've sort of come at it from frontwards from the game, where the game is re-initialized everything and resetting the lives counter, and then we've come at it from the other angle, where the game has decided to call the game over routine because the lives are 0. So yeah, not the longest video, but so the last video was quite long. But so I thought it'd be interesting just to see how you go about using a monitor to actually sort of go about finding infinite lives. And I say Wizball, it's quite straightforward. As I say, we didn't have to do a lot of searching through those lists. I say the first entries in both of those methods yielded good results, and the program hadn't done any sort of obfuscation or used any sort of like, I think Green Beret or something like Jonathan Smith they tend to use the IX register to sort of to uses that to index into a structure, which then the life counter isn't as you don't sort of see it as like a specific address. But as I say, this one was quite straightforward. So cheers for the Wizball programmers for making it easy. So this video wasn't too long. Anyway, so yeah, still work continues on the monitor, but it's getting there. So it's probably going to get released by the end of this month. So you'll get an alpha release of that, so you can have a play about with it. So yeah, thanks for watching, and I shall see you in the next video. Bye for now.